Hi everybody, I am working through the Electricity 2019 question 3, counting cars. So I've just printed out this page on question 3, but the image is lost. So capacitors are built into rubber speed bumps, can be used to sense the number of cars entering and leaving parking buildings. One particular speed bump capacitor consists of two 0.687 meters squared, that's the area, metal plates. When no car is present, the plates are separated by, and this is your distance, 0.0519 meters of air, and that's the relative permeability. Show that the capacitance of the capacitor is 1.17 times 10 to the power of negative 10 farads. So for this, so this is a show that question. So the formula is C is equal to 0 ER A over D. So that is 8.85 times 10 to the power of negative 12. Now that's on your resource paper. This is your dielectric constant, which is 1. And the area is 0.687 meters squared, and the distance between them is 0.0519 meters. And then you put all that into your calculator. You get 8.85 exponent negative 12 times 1 times 0.687 divided by 0.0519. And I'm getting 1.1714 times 10 to the power of negative 10. It's capacitance, so it's in farads. So you always give the unrounded number for a show that question, and then you write it again and say that's equal to 1.17 times 10 to the power of negative 10 farads. So that's one. Okay, the next one, the capacitor is connected to a sensing circuit as shown below. So here it is. So that's your battery voltage. Here's your capacitance. That's a resistor of 12 ohms, and you've got 2 voltmeters. And the meter measures the current. Okay, so when the switch is closed, the current will begin to flow and charge the capacitor plates. Sketch a graph to show how current changes from when the switch is closed to when the capacitor is fully charged. That means the current stops, and calculated values for at least 2 data points should be included. So this is a current versus time graph, and your I, so you go from 0. Now I don't know the values of I don't know the value of T. So these are the things I need to find out. Your maximum current depends on your source voltage and the resistance. Your source voltage is 6 volts and the resistance is 12 ohms. So you just go 6 divided by 12, which is 0.500 amps. Now your time is to do with time constant. Your time constant for a resistor capacitor circuit is RC. So your resistance is 12, capacitance is 1.17 times 10 to the power of negative 10. So I just go 12 times 1.17 times 10 to the power of negative 10. And then on my calculator, I go 12 times 1.17 exponent negative 10, and I get 1.404. So I get 1.404 times 10 to the power of negative 9 seconds. So that's my time constant. So I'm just going to write times 1.404 times 10 to the power of negative 9 seconds. And I'm just going to write, this is 1t, 2t, it's hard to see, 3t, and so on. Okay, so at times, and then at time 0 your current is a maximum 0.500 amps. So this one's really hard. So let's say 1, 2, 3, 4, 5. 0.500 amps. This grid is really bad. Okay, so this is 0.100, 0.200, and so on, 3 and 4. Now, so at the start, time 0, your current is a maximum because maximum current flows at time 0. After one time constant, it's going to be a decay curve. So after one time constant, it is Imax, which is 0.500 times e to the power of -1. That's how you get the current after one time constant. So Imax is 1.404 exponent negative, oh no, 0.5, sorry, 0.500 shift e -1. So 0.184 amps. So 0.184 amps is somewhere over here. And then after two time constants, it's 0.500, which is your maximum current, times e to the power of -2. So you get 0.500 exponent e -2, and I get 0.067. 0.067. So after two time constants, so it's somewhere over here, and then you just draw your decay curve. Okay, so that's how you get that question. And then what happens is, after the capacitor has been fully charged, a car passes over the speed bump. The weight of the car pushes the capacitor plates closer together, increasing the capacitance to 2.30 times 10 to the power of -10 farads. Assume the amount of charge on each plates at this moment is unchanged. Show that the voltage changes to this value. So we need to find out what is the charge. So the amount of charge we need to get from our initial one. So Q is equal to Q over V is equal to C. So Q is equal to C times V. Your initial capacitance was 1.17. So that's 1.17 times 10 to the power of negative times 6. How would I get 6? 6 is your battery voltage, okay? Because when it's fully charged with this, the current stops flowing and the voltage across capacitor becomes that at the capacitance. So I just go 1.17 exponent -10 times 6, and I get 7.02 times 10 to the power of, so this becomes 7.02 times 10 to the power of -10 coulombs. So that's the amount of charge on the plates, okay? Then you use the same formula but with a different capacitance. So voltage is equal to Q over C. So now your Q is 7.02 times 10 to the power of -10, and your capacitance is 2.30 times 10 to the power of -10. So if they're both 10 to the power of -10, so they essentially cancel. So you just go 7.02 divided by 2.30, and you get 3.0521. And that's your voltage, which is 3.05 volts, and that's what they wanted. Okay, and then there's the very last question, which I'll just quickly go through. So explain, this is probably an excellence question. When the moment you see this word explain, that's usually excellence. Okay, explain the effect the new capacitor voltage will have on the readings recorded by the ammeter and voltmeter 2 immediately after the capacitor plates are pushed together. So which one is voltmeter 2? This is the voltmeter across the resistor. So we need to know what's happening here, what's happening there. So so there's going to be a potential difference. And the reason why there's going to be, and the potential difference is the battery voltage is 6 volts, and this difference is 6 minus, and we just found out the voltage across the capacitor is 3.05, so that's about 2.95 volts. Now whenever there's a potential difference, there will be a current. Okay, this will cause a current to flow momentarily, because because more charges can accumulate on the capacitor plates. That's what happens when the capacitance increases, isn't it? So this will cause a current to flow and accumulate on and cause more charge to accumulate on the capacitor plates. So now they want to know the size of the current. Now the size of the current is given by this potential difference divided by the resistance. So it's the resistance of the resistor that determines the size of the current. So it's 2.95 divided by, and I've forgotten what the resistance is. So if you go back to the initial diagram, the resistance is 12 ohms. So if you divide that by 12, what do we get? So you go 2.95 divided by 12, and I get 0.2458. 0.2458 amps, which is, to three significant figures, 0.256 amps. And that's the maximum current. So this is the maximum current that flows through. So have I done everything? So explain the effect the new capacitor voltage will have on the readings recorded. So because of the potential difference, okay, so the voltmeter will read that, because the supply voltage is equal to voltage across capacitor plus voltage across resistor. So at all times the total is equal to the sum of those two. So the capacitor voltage is already 3.05, and that's your total. So the voltage across the resistance will be 2.95. That is why. So this is the reason. And this will cause a current to flow. So that's your answer for question 3. I hope that made sense.